we are going to have Robert Park, who is a member of the MIT App Inventor. Actually, he's an expert in curriculum, okay? And he's going to give us a curriculum developer at MIT, okay? And he's going to talk about really what he has done at MIT and what is going to be his presentation. Okay, Robert, the mic is yours. So,
Okay.
so we have students from Puerto Rico, and also I was telling you we have a group in Tunisia, headed uh, by the professor. He is Moes. Okay, he's a he's a artificial intelligence professor, and he was a Fulbright at Berkeley last year. Okay, he has a Fulbright visiting scholar. All right, uh, Robert, let's go forward.
All right. Well, thank you very much to Dr. Ratia for inviting me to talk with you. And I'm so pleased to have a chance to talk with you about data science and IoT. That's my specialty at App
Yeah.
Inventor. How many, you can maybe just raise your hand in the chat or in the chat, or you can react in the Zoom. Say how many people have. I know you've talked with my colleague Salim and also with Natalie about App Inventor. How many have tried App Inventor before?
Oh, probably we had Ana Lucia. Ana Lucia, she's a 13-year-old lady, and she has learned App Inventor by herself. She's a homeschooling, so that's outstanding. Yeah,
Oh,
and
that's
the and the rest actually they are learning. You see, they are learning the process. Yeah.
well, let me share some screen about one of the presentations that we use. Uh, We are doing some data science work where we use App Inventor to show the data. And that could be from sensors, from a microbit. I wish I could show you my desk is covered in electronics. Or maybe I'll just dip this down here. I've got a lot of electronic gear and a multimeter and everything going. So we have sensors, but we also have data from the internet. A lot of times you get a chance to get data from maybe a community website or a government website, and it's really important to climate change or something like that, but it's hard to make sense of. So we're working on systems that will let you look at the data on a phone and then send it to your friends and say, hey, this is an important issue and I want to talk to you about it. Um, I think people have talked to you a little bit about computational action, which means kind of not what we want to do with the tool, but what problem we want to solve primarily. And then we bring the tool in to solve that problem. So some of the problems that we're thinking about are how to have people conserve energy and maybe protect water from pollution. And so working on that this year. Let's say an example of, this is just an example of a high schooler who wants to talk about how there are great opportunities to find fresh, wholesome food in her community. And so she finds a government database and she's able to make a pie chart with that on App Inventor. And then she's able to make a community garden and monitor the garden and optimize it using different sensors to figure out the soil moisture or different parameters for the garden and make the plants grow a lot better.
Ok, gracias.
You've probably seen that you program App Inventor with these blocks, and then you take your own phone. We have Android phones and iOS phones, and you hold that in front of the computer, in front of your code, and it gives you a little code to put it on your phone to test it, and then you can put it permanently on your phone when you're happy with it. So we've got all of these different data science apps that I'm excited. I may get a chance to meet some of you in the summer, and we can work on some of these apps together. But we have one here on the left that takes data from a sensor and plots it as a graph. And then the next one is all the dogs in New York City, they record the name in the government database. And now you can put a pie chart of how many dogs are named Blackie, Charlie, Rufus. So some of the most popular names are there on the pie chart. And then this one here, second to the right, shows some of the ice buildup in the Northern Hemisphere and how there's less ice every year. So that's something concerning. And in App Inventor, you can send that data to an AI agent and say, hey, what do you think? It's great for brainstorming or finding patterns. And so up there at the top, that text with that graph is something where the AI has responded and said, here's my take on it. It's often very useful to start your research and look for areas, brainstorm areas to do more research. And then the app on the far right is one that students made to gather information on their peers' attitudes and feelings. So sixth graders created this app to do a poll. So not all data comes from sensors or from government databases, but going around to people and asking their opinion. And as an example, these sixth graders asked their opinion of how do you feel today? Do you feel happy, angry, or sad? And so they were able to create an app that would log that every day and maybe see a trend that people are feeling better day by day because of a certain thing or something like that. So we've been running these with lots of different workshops, and I'm excited to see what you guys will do with it, just to find out some of the ideas that you have. We're trying to think about ways to make this something that feels important. That these tools aren't just things that come and go. These are tools that may stay with you. You may be used through your college years, and ways to analyze data and solve problems. And so you could solve problems in your family, in your school, in your community. I might be asking you a little bit later, like how would you use this tool? I'm going to demonstrate a few things. And we've also been putting sensors in plants. And the way that is really effective is this sensor here is not that expensive. This whole thing is fairly affordable. And what it does is the computer to the bottom right is a microbit. Has anybody used a microbit? Could anybody raise their hand in the chat or in the Zoom as a reaction? Has anybody used one of these computers? The lower right in the main picture here is a little microbit. Anybody? Oh, and Lucia, great. Oh, and Mohammed, excellent, excellent. These are really powerful devices, very small and useful. And what they do is they have a little bit of computer power to gather data from sensors, but they also have Bluetooth. And of course, everybody's phone has Bluetooth. So if you're working with an app, you can turn the Bluetooth on and you can have it connect to the microbit and gather data from that. So what's connected to that microbit is a bunch of wires, right? You see, and those wires are connected to the sensor, and the sensor is getting the moisture in the soil, how wet it is, the light around the plant. So is the plant getting enough sunshine? And the temperature around the plant, because we know that even a plant getting enough sunshine and enough water if it's in the middle of winter and there's very cold days, you're not going to have a good garden. So all those three factors have to come together. And you can plot that in an app. We have a starter app. And what I'd love to see you work with is I can give you these links and you can start with this template, but you could make it your own. You could change the design. Maybe you don't like that weird purple background, but also maybe you don't like the way it's presenting the data. It could be presenting the data in a different kind of chart. Um, what would you do to change that interface? What's a different kind of chart that that could show the temperature and the humidity and the moisture? If you want to answer in the chat, that would be great.
Perfect.
A different way to visualize that data. Because we saw earlier, we saw pie charts, and there's other kinds of charts. What's another kind of chart that could show you the day, every day, how much light, temperature, and humidity is getting? Oh, sorry, light. It doesn't have light there. We did add light. How much temperature, humidity, and moisture the plant is getting. You could do, so let me go ahead and answer. You could do a bar chart as well, right? So you could have these things shown in this way, and that would be a different way of presenting the information. It might be a good way of showing the growth of the plant and the more light as the seasons change. And then up top, we have some analysis of how the plant is doing from an AI. And I don't know if this might be a little bit too silly for you, but I changed the AI to make it talk like somebody from 100 years ago, because you can have the AI just talk in any voice. So I said, please talk like an old-fashioned person. Let me unfold the tale of my existence. That's what the plant is saying. So anyway, uh, data cleaning. Do you see some problems in this data? This is data from people who go to lakes every year and find out how many days that lake was frozen. I don't know. I imagine there are no frozen lakes in Puerto Rico, but
Yeah.
in many places in North America, lakes freeze for a couple of months, every winter. And that's important because it's very important for the fish and the wildlife to have this change. They have evolved to depend on this change in the lake ice. It keeps the lake ice cold by having a cover of ice over it. And so there are lots of important uh, reasons why lakes freeze, and if they're in a certain environment, they need to freeze. So people go and they say, well, uh, in October or November, we saw this lake freeze, and now people are ice skating on it all winter. And then in March or April, we see this lake unfreeze and break up and become water again. And that's the number of days that it's frozen. So over time, we're seeing a trend that it's getting less and less frozen. But also in this data, you got to watch out when you look at data, especially from someone else that you're not aware of how it was collected. What do you think? Do you see any surprising features of this data?
Any reaction from the audience?
Any reaction from the audience? Do you see anything that sticks out?
Yeah. Wow. Okay.
This is a very good tools for us because the student have more interesting from investigation. I think so.
Yeah,
Right.
I think, Robert, yeah, this is a very interesting component what you are talking about. Because, yes, I was sending some message to some teachers, yeah, about their project. And this is what we are talking about. You see, they had to just focus from now until May in what they are going to develop using MIT App Inventor. So what you are giving them is just exactly what they need at this time just to decide what they are going to do. Yes, right.
We have a lot of exercises where we intentionally leave it not completely done. We hope
Yeah.
that students, they may use it for a whole different reason. We just want to get you started. And we're also giving this data and saying, hey, this is real data that we found with all of the ugly problems or issues that might come up with real data. So this is actual data that we got off the internet. And as you can see, there are a couple of zeros. And so if you look at the bottom row is the time, it's the x-axis. And the time is 1985, 1986. Somebody went and got the number of days of ice in this lake in 1985, and that was 135 days of ice. And then they went back to the same lake the next day, the next year, and they took measurements and they found out that 113 days of ice happened in 1986. And then in 1987, they found that there was 0 days of ice. Does that sound right? I mean, climate change is happening, but it would be surprising if suddenly this lake that everybody was skating on was completely water all through the winter. So what we found out was that in 1987, someone forgot to take data. And so in the spreadsheet, when it shows up, there's just an NA there. And when you graph it, it comes out as a 0. So you always have to watch out, like, and understand the context a little bit. Sometimes you have to be a little bit like a reporter, like a newspaper reporter, and say, well, who took this data and why are there zeros there? So you get rid of the zeros, and then you find that you can put a little line across all the data. See on the left there in the app, there's a line that goes through. And that line is declining. That line is trying to summarize all of those data points. And when it summarizes it, it shows that it's going down. So that's worrisome. Over 40 years at the lake, there's less and less ice. And so we're trying to figure out maybe that is climate change. And when scientists look at 3,000 lakes in the Northern Hemisphere, they say that same model, that same line is declining. What that line does is able to summarize the data. We're able to say, yes, it looks like a decline, but it's also able to tell us the future. It's a fortune-telling line. That line is telling us about what might happen 100 or 200 years from now. How you can project that line way off to the right, and you can say how many days of ice could be happening in the future. We're doing a lot of different things with sensors. We're using this microbit, and I'm glad Ana Lucia and Mohammed have been using microbits. We have a lot of neat things we can do with them. Here we're just taking light data, but we're also taking water measurements around our community and comparing them to the government measurements in dissolved solids. And I can actually set that up for you in a little bit and see, graph that and see, is the water getting better or is it getting worse in different spots around the community? And we're able to put, if you don't want to put your own phone maybe at a testing spot, but many people, I know in my family, sometimes when we upgrade our phones, we have the old phone in a kitchen drawer or someplace around the house where you have an old phone. That's perfect for App Inventor. You program it with a data collecting system, it's data collecting app, and by Bluetooth, it grabs data from the microbit. And then you might be able to put it for a few days, near your school or someplace that's safe, and be able to see the data on a spreadsheet come in Google Sheets. And that's exciting because you can kind of remotely take data and start to make sense of it that way. So I wanted to try an exercise that we do called slow reveal graphs. And what that does is we get to start to understand what different graphs can tell us. So I'm going to turn this into a slideshow. And what do you think this graph is? What do you think this is going to be about? And students or teachers can answer. We're gonna take this graph one step at a time.
Excuse me, this is milk, right?
Those are milk jugs. So what do you think they're trying to? Oh, I'm glad we get some stuff from the chats. Milk jugs, yes. The consumption of milk. A bar graph. Great. Ana Lucia, Iria talks about how much milk is consumed and how much milk is consumed per state. Mohammed thought that's good. It's water. It's gallons of water used per day. And what are they measuring?
Well,
Gallons in what context? Gallons of water used per day at the gym, or maybe at the gymnasium, or maybe at the beach? What do you think that the context is in this?
maybe at the school.
At
Yeah.
the school? That's a good one. Let's see.
Yeah.
Okay. We got water uses in the home.
In the home. Oh,
In the
wow.
home. And so
Wow.
this is average North American water uses in the home. And that fourth bar is in sinks, and in the bathroom or in the kitchen, the sink.
Yeah.
What are
Oh,
some of the, what do you think? What are some of the other quantities measured by this?
yeah.
Okay, let's do another one here. Taking a shower. Oh,
Yes.
bathing, good. Bathing and laundry, good. And washing clothes, yes. Laundry.
Yeah.
Bathing and laundry, yeah, great. Showering, perfect. Um, uh,
Cooking.
Irado said bathing and laundry, really good. Thank you. And let's see what we got. Oh, flushing the toilet, that uses the most. So that's
Toilet.
surprising to me.
Wow. Wow.
Yeah.
Interesting.
Yeah, because people do replace their toilets with those low flow toilets, and some people have a lot of consciousness around flushing the toilet. But some of these toilets are really old, and they flush a couple of many liters each time, or gallons, and they need to be replaced, and that's what the statistics for all of North America are. So it's something to be thinking about. I want to encourage students to be thinking about projects that they might use with sensors, or ways of making sense of data, just like we did with the water data. What are different ways of presenting it in an app? different ways of collecting it. And some of the new projects that we've been working on. So let me see. I wanted to show you a couple of the things. We've been working with a heart rate sensor. So that connects directly to App Inventor with no microbit. Usually we have the sensor talks to the microbit, and then the microbit talks to App Inventor. And there is a picture of a microbit here, but we're just using the sensor directly to App Inventor. And this app that we created here on the right shows a day in the life of actually me wearing the heart rate sensor and just trying to see if there are any patterns. There are places here on the top there where we're showing the heart rate during the day, and there are places on the bottom where we're showing the movement. So we do have a microbit because we are taking the acceleration of the microbit. I had it in my pocket, and I had the heart rate sensor on my chest, and I was looking at places where I was taking a walk, and I noticed, I don't know if you get this way, but I felt a little anxious in business meetings, because you have to talk, and it's not only anxious, but you're also excited and you're having fun and you want to say the right thing, but that makes your heart rate go up. So I noticed when I'm working alone, you can see these dips in my heart rate for a whole hour. And then you can see an hour where ooh, I was having a meeting, and I was maybe having to respond to questions or having fun with colleagues, and that made my heart rise. And then you see the heart rise really high there on the right, and that was from when I was chopping wood for a little while and doing some exercise in the yard. But there's a lot of different things you could use this for computational action, for looking at ways of solving problems in your school. Maybe you had some people who are willing to be test subjects, and you find that people are more anxious in one certain class than another certain class, and you can maybe they don't like math class, or maybe people are really comfortable in math class and they don't like this other class, and you can see that in their levels of heart rate. Who knows? But it's something, maybe it's something to look at. We've been looking at water quality and going out into the community and gathering water. I love this project that used App Inventor in Africa, where students took wind measurements and found where in their community had the best wind for wind turbines to be installed. So they went all to different locations and used App Inventor and used a homemade anemometer. Anemometer is a technical device that measures wind, and is basically very clever. They used a little generator and a microbit and a bottle for to create the wind turbine, and they measured wind in different locations and mapped them all over their community to figure out wind provisioning, things like that. So I also want to talk a little bit about sending data out into the world, making changes. And we can experiment with this as we go, and as you look at the materials from App Inventor, or maybe when we meet this summer, we can talk a little bit about making motors go using an app. So the microbit also sends data to the microbit and says, hey, maybe switch this motor on. And so you can connect a servo motor to make something move. If you put a lot of servo motors together, you could make a robot move. You connect it with simple wires, and maybe make the robot obey the body landmarks. App Inventor has an AI component that you can freely use in your app when you're building your app, where you put body landmarks, let's say an arm or a hand or your head, and wherever the head moves, it gives the angle. So you feed that angle over to the motor, and you can make something, maybe make something move. thinking about solving problems. This could be something that would help somebody maybe with an injury, that they could like raise their hand and they could like raise the desk automatically without having to use their muscle power. Maybe they have a diminished strength for some reason. Who knows? But I wanted to end on a live demo of a new thing. This is something I'm testing, so if it crashes and burns, please forgive me. But I've been working on an app that, and then I want to take some questions. But like for the next couple of minutes, I want to show you a new app that we're working on. We're always trying to figure out how to connect different sensors to App Inventor and maybe give you different avenues for solving problems, for thinking about ways to create a solution that you would like to see in the world. So we have our this is our this is a way to show an app on my desktop. This is actually my tablet right here. You can see that it has a wire connected and it's connected right to the computer. So you're seeing my phone. It's basically a big phone. A tablet is just an easier way to work with apps because you got more space. You can make a bigger user interface, and then you could scale it down for your phone. But for everybody to see, I made this interface. And what I'm going to do is I'm going to connect App Inventor to an app that I made last night. Let's see. Maybe I'll show my whole screen. There we go. So I'm going to go into App Inventor. And I'm going to have the app sync this app with my phone so that I'm able to get a sense of how it works. Let's see. I'm going to put the camera on this QR code. And now I've got the app coming into my phone. Now I want to, I've got this, here's my microbit. And today it's connected to a small, can you see this small sensor here? This is a sensor for sensing different types of air quality and gas. So this sensor is for methane. And I was curious if we could use this sensor with the microbit to maybe test for problems in the air. Let's say you have a dangerous place where there's a lot of methane buildup. This can happen in farms where suddenly there could be a fire because there's way too much of this waste gas and it's not being sent out with a fan. So this is something that I got the other day, and to connect it to the microbit, you put the microbit's name in, and then it goes through Bluetooth, and then it starts gathering data. And you maybe not see the unit, but the unit is 646. So this app is now taking data from the sensor. And what kind of things do you think would maybe we could test with methane? What would react with methane? When it's connected to App Inventor, there's a little. Some of you said you'd been using microbits, and so we programmed the screen to have the little guy standing up straight. And we know that there's a little bit of feedback that when the guy's standing up straight, that means it's connected and taking data. So we're good to go. So methane is created by, among other things, things that are rotting. So let's say maybe that you have a problem with people, and this is a problem that we have at MIT, I gotta admit, it's a problem with people leaving rotting food in their refrigerator, and they go off for the weekend and they forget about it. So let's see if this could help. We could put this in the refrigerator and create an alarm to automatically send an email to say, hey, please clean up the refrigerator before you leave for the weekend. So keep an eye. Can everybody see the, there we go. Here's the data. And now it's happening every 2 seconds. I'm going to change the interval to every half second so that we can see it change more quickly. There we go. Okay, so it's pretty flat. It's going up and down. But when we take I've got an old banana. I'm going to take the old banana. I'm going to get it pretty close to this sensor and see if there's any kind of a change. Not really much of a change. Oh, it's going up a little bit. All right. Well, I got to admit that I fished around in the garbage this morning and I found an old can of cat food. I have a little orange cat, and sometimes the cat food in the can gets a little bit old, and so I was trying to think of things that would cause methane. So let's take this can here. It's got some yucky stuff inside of it, and let's bring it near the sensor. Okay. Oh boy. Okay. So
Wow.
let's say that you had something really yucky in that refrigerator and you couldn't figure out where the smell was, or how to solve that. You could have this sensor and then an app inventor in the blocks. I know some of you have used App Inventor and some of you haven't, but you could say, what is the value that is coming in? And we said it was around 700. But when it reaches 800, we might say, get an if-then statement, a conditional. We might say, if it reaches 800, send an email or make an alarm sound on the app, or send this information to the AI and have a Gen AI agent tell us what to do. Say that this is happening over the last 3 weekends and they see a pattern. We can have AI give us analysis of what might be the pattern. Could you, as a last thing before we take questions, could you respond in the chat of ways that you might use this sensor to solve a real problem? Are there problems that you can think of that that you might make use of a gas sensor or an air quality sensor?
Yeah. Good.
Cooking. Oh. Well, that was from the last. That was Ana Lucia's from the slow reveal graphs. Oh, trash cans in the school.
Yeah.
Queria. Food left in lockers. Really like that. Mohammed. Oh, yes.
Yeah.
Smoking in the classroom. These sensors do seem very similar to ones maybe in the air, in different places where they can detect smoking. Or even harder to detect vaping. Check if refrigerator food is still edible. That's a good one because in my household, we kind of pass it around and say, would you eat this? But maybe if we had an objective system, we wouldn't have to go through that process each time. These are all really good answers. Any last answers? Anybody else? This is terrific. Well, thank you so much. Let's check in quickly on the graph and see where we are here. Oh, see, now we removed the cat food, and we're back to a low level of good air quality. So that's reassuring. Oh, we've got Ana Lucia saying that we could check air quality in communities. That's a really good idea. And as an extended project or something that you could do with the support of a teacher, maybe you could put an air quality sensor like on a roof somewhere with the permission of the property owner, something like that, and take some measurements over the course of a week or a month and see if there's change, depending on how many people are using the road nearby or some other factor. Are there questions or Dr. Aratia, what do you think we should, any questions?
Yeah, I think this is the moment for them just to target exactly what they can do or explore, you see? And this is it. Because there are also somebody who has problem in connecting is Daniel Leaks, and she was asking me exactly all these questions. So it will be interesting because we already taped this conversation. So I'm going to send the link for the tape for this conversation. So she will have the answer in terms of different options, okay, for the student, because that was she was asking me, okay? So no, I think, Robert, it has been really interesting, you see, to target the student in their next step in this project, okay? Because they are receiving a lot of feedback, a lot. You see, you are the fourth speaker, and so they have good ideas, very good. But this particular your presentation, it gives specific ideas, okay, integrating whatever they have, or maybe they just go and look for data. You see, there is a lot of data going on, so they can just do that. And because what I'm going to do, you see, they are going to be the presenters in the next sessions to see what they are doing. So everybody will help, you see, just to finish that, okay, to finish their project. So I think that will be a good way of pushing them, you see, just to look for something pretty fast and try to work with feedback from us, okay? So that's what I have from my end. I'm not sure if the other teachers or students, they can give a comment for this conference. Yeah, a public one, so everybody will have. Jiria, yes.
Yiria, so purchasing the sensors, we get the microbits from you know what, I'll send some links to our tutorials, and I'll send links to where to get the sensors. The microbit, which is the computer brain that serves as the bridge, that's about $19, and that is available at a couple of websites that I can send. And then the sensors really are most of them are under $10. And so that gas sensor or the water quality sensor is under $10, and then the heart rate is about $30. And then we have one that does the pH of water, and that's the most expensive one we use.
Perfect. Any other question for Robert? Yeah, this is important because yeah, now we are going to start hearing from the participants to see exactly. Yes, here is something else with
Is MIT App Inventor? That's a really good question. I am more I like Arduino and ESP32 as well. And MIT is definitely compatible. We don't have a tutorial on it, but we have this wonderful community of users who compare notes online. And so I can send you the links to this. I think he's a Colombian gentleman who wrote all of the documentation on how to use Arduino with App Inventor. And you can either you can use the App Inventor with the Bluetooth on it, or you can add a little Bluetooth module to the App Inventor. I'm sorry, the Arduino. You add a little Bluetooth
Yeah.
module to Arduino.
Yeah, perfect. That's beautiful. Okay. Thanks. Sorry.
Do you think MIT App Inventor has limitations we should be aware of? Oh, that's a really good question, Victoria. Limitations when we develop applications. Yes. Right now, a lot of people use iPhones. So, the world is split between iPhones and Android phones, and I mostly use Android phones. But the iPhones work for developing the apps and looking at and testing them and keeping them on for about if you're having the app work for about an hour, or maybe working with it near App Inventor, then iPhone is great. But Apple, you know how fussy Apple is. They don't let you install the app on the phone unless you pay this big fee and go through all this paperwork. So Android is better if you want to have a real app on your phone that you can then take out in the community and use as a way to take surveys or gather data, things like that. That would be the biggest limitation I would think of.
Perfect. Yes. Good. Here. Yeah, Victoria. Thanks. Hey, Rosario, do you have any question? Rosario?
It's very, very interesting because yesterday I looked the different sensor in MIT in one tutorial, and we need this sensor in this time from my project. I need one from my students.
Oh, perfect. So
Great.
you are doing progress with that. That's great. Yeah. Perfect. Yeah. No other question for Robert this time.
Ana Lucia?
Yeah.
Hello.
Yeah.
First of all,
Yeah.
thank you for your conference. I really like the topic about data science. And I would like to ask if you have used before any type of data from NASA in any MIT App Inventor app, and how have you used it?
That is an excellent project to work on because in some cases, NASA has what would we say, curated or groomed or brought the data down to something that is usable by a student. I find that NASA data can sometimes be, 100,000 rows or 1,000,000 rows, and it tells you all about the change in temperature of the ocean or something like that. Wonderful data, but unless you're expert in Python, which would be a great next step, to bring 1,000,000 rows down to something that could be graphed on a chart would be fairly difficult. So there are a lot of great databases, and for a student, I would recommend starting with a website called This World in Data, or Our World in Data. And what they do is they take all of those difficult NASA databases and bring them down to maybe 5,000 rows or 10,000 rows, which is easily something that you can graph and analyze as a student, and not as like a a
Question.
college student working in data science.
Yeah,
Thank you.
great. Thank you much. All right, Robert. Thank you very much for your time and for the information you are giving us. I think it's going to be very interesting. And also, I believe you will be available for any question, right? Just
That's right.
yeah, for the student, yes, a student and teacher will be available. All the group of MIT App Inventor.
Of course.
So, thank you very much, and see you sometime in the future. Right?
Nice to see everyone. Thank you so much. Bye-bye.
Thank you, Robert.
Bye-bye. Yes. Bye-bye, Noes. Yeah. Take care.
Thank
Yes.
you. Goodbye.
Bye-bye, Lucia. Yeah.
Thank you for all. Thank you.
Yes. Yes, Rosario. Good. Yeah, Patricia. Great. Yes.